Hello, my name is Maridely Oviedo. I am going to present my project entitled Synthesis of Silver Nanoparticle of the Spectrophotometric Detection of Ciprofloxacin. Abstract. Ciprofloxacin is an antibiotic of the family of fluoroquinales, which is frequently used in aquaculture to treat many animal diseases. Many recent reports indicate that this antibiotic, as well as many other drugs, can accumulate in the environment, resulting in threat to human and animal health. For this reason, the development of new methods for detection and quantification of these drugs is of great importance. In this sense, the novel metal nanoparticles are promising candidates for the colorimetric sensing of many analytes due to the collision oscillation of free electrons in response to incident light, localized surface plasmon LSPR. The intensity of the LSPR of metallic nanoparticles is in function of their chemical environment. In this work, we report the synthesis of silver nanoparticles by chemical reduction and its use for the spectrophotometry detection of ciprofloxacin. Two different particle sizes were tested: small particle around 10 nanometers and large particle around 60 nanometers. The results demonstrate that silver nanoparticles can detect ciprofloxacin and concentration of the 5 microgram per milliliter, and the small particles are best candidates for ciprofloxacin detection. Methods. Silver nanoparticles were prepared by reducing silver nitrate with sodium borohydride as reducing agents and sodium citrate as stabilizing agent, seeking to obtain two different says. Method A and Method B. For the synthesis of Method A, nanoparticle 40 ml of the aqueous solution, the sodium borohydride, 5 times 10 to the negative 4 molar, and sodium citrate 3.55 times 10 and less 3 molar, with vigorous stretching for 30 minutes at 16 degrees Celsius. Then 10 ml of silver nanoparticle 2 by 10 and less 3 molar was anided dropped with subclentity. The temperature was raising to 90 degrees Celsius. The pH of the solution was adjusted to the 10.5 using 0.1 molar sodium hydroxide. Heating was continued for 20 minutes. The nanoparticle suspension was allowed to cool to room temperature to remove reductions. The silver nanoparticle suspension were centrifuged 12,000 revolutions per minute for 45 minutes, and washed once, followed by redispersion in the ionized water, and finally stored for the future use. While for the synthesis of nanoparticles by method B, 48 ml of an aqueous solution of sodium borohydride 2 times 10 to negative 3 molar and sodium citrate 3.550 times 10 to negative 3 molar were prepared with vigorous staging for 20 minutes at 60 degrees Celsius. Then 2 milliliters of silver nitrate were anide drop by drop, one broil. 1 by 10 and less 3 molar, the temperature was rising to 90 degrees Celsius. The pH of the solution was adjusted to 10.5 using sodium hydroxide, 0.1 molar. Heating was continued for 20 minutes. Result. In the figure 1, I can be see that the nanoparticle present an absorption band near 400 nanometers, which is characteristic of silver nanoparticle. The silver nanoparticle synthesized by method B present a great bandwidth and shift toward the left which tell us that we have a smaller 6 of nanoparticle. In figure 2, we presenting an scheme of the interaction of silver nanoparticle with the analyte in which ciprofloxacin favor the agglomeration of nanoparticles which allow their detection due to the change the absorption spectrum. In the figure 3, the red color spectrum represents the interaction of silver nanoparticles synthesized with method A and ciprofloxacin. The change in the spectrum is very slight, presenting a decline in the intensity of the nanoparticle band that is a log of 400 nanometers, a slight shift to the right. However, in the figure 4, the red color spectrum presenting the interaction of the silver nanoparticle synthesized with method B and ciprofloxacin, which is presenting a decrease in the intensity in the nanoparticle band that is a leg of the 400 nanometers, indicating the percentage of ciprofloxacin. Conclusion: silver nanoparticles were successfully synthesized by chemical reduction and used for the spectrophotometric detection of ciprofloxacin. The result demonstrated that, according to the mu theory, the different particle sets will form method A, large particles around 16 nanometers, and method B, small particles around 10 nanometers. Moreover, silver nanoparticles synthesized by method B can detect ciprofloxacin and the concentration of the 5 micrograms per milliliter due to the dramatic change in the absorption spectra caused by the aggregation of nanoparticles.